Welcome. My name is John Norton, and I'm a co-founder of Phase 3 Lab Solutions, a company that provides products and professional service to cannabis labs. Today, I'm going to talk about quality as a strategic business plan and operational model, and how a focus on quality will yield profitable results. The cannabis industry is exciting and offers entrepreneurs an abundance of opportunity to profit. One area that's required to ensure the ongoing success of the industry is in the safety and quality testing of the cannabis-based products. The regulations for cannabis vary from state to state. However, every state requires some level of testing. Entrepreneurs envision testing as a great opportunity to profit from the industry, where there's an increasing need for more testing capacity. Overall, the U.S. market is forecasted to grow at an annual rate of 20%. Considering profitability for a moment, operating expenses for a lab with staff are estimated to be about $19,000 a week. The potential revenue from a single set of instruments is roughly $53,000 a week. When problems delay the lab from generating income, the missed revenue is considered opportunity cost. Combining operating expenses with missed revenue, the average cost of delay is estimated to be $72,000 a week. At this rate, the lab desperately needs to start generating sustainable revenue as quickly as possible. Unfortunately, through Phase 3 Lab Solutions, we are seeing avoidable delays ranging from 8 to 18 months, accumulating anywhere from $1 to $5 million of lost value. So why is this the case? In order to comprehend this problem, it's important to recognize the lab's ultimate value in the marketplace depends on the quality, accuracy, and reliability of the test results it produces. Yet, in the desperate urgency to generate income, startups unintentionally cut corners, compromise quality, and unwittingly sacrifice the sustainable revenue they're trying to capture. The most common approach for cannabis lab startups in the U.S. is to find a location, build out a facility, acquire state-of-the-art instruments, hire consultants to validate methods, get a provisional license, patch together a quality system, and then struggle to get accredited before the provisional license expires. This struggle is completely avoidable by simply reconsidering priorities and the sequence of startup activities. Although it's common for 2 years to pass before a cannabis lab generates revenue, it's not a 2-year process. Many other labs in other industries get started and accredited in as little as 6 months. With quality as a strategic business plan and operational model, cannabis labs can go from instrument installation to accreditation and sustainable revenue generation in 6 months or less, avoiding millions of lost value. This value generation and speed is only possible with a commitment to quality based on the tenets of ISO 17025, the international standard for laboratory competence, and with a management system that's designed and optimized for a cannabis lab. An operational model that's supported by a logically structured QMS ensures that the lab can deliver predictable and sustainable results. The QMS also addresses many aspects of the business plan, as well as how the laboratory operates and delivers accurate and reliable results. With quality as a strategic business plan and an operational model, every decision is made within the context of achieving predictability. Before getting into specific solutions, it's important to identify and examine some of the common startup mistakes when planning and operating a cannabis lab. The first mistake is related to the sequence of startup activities. The typical sequence begins with the facility build-out, instrument selection, installation, and then hiring personnel. Following these milestones, labs think that they can quickly move to validating their methods and obtain accreditation. Sounds simple enough, right? But as you may know, the validation stage is the most difficult stage of startup and where so many labs implode. It's not that the preceding activities are inappropriate. The fundamental problem is that the activities are performed out of sequence. Early decisions are made and milestones are passed independent of a QMS. Through Phase 3 lab solutions, we often see that a lab's QMS is either missing, inadequate, or not being followed. This leads to developing bad habits, poor record-keeping practices, fragmented documentation, illogical workflows, and all-around confusion. All of this translates into lost productivity, frustration, invalid methods, and challenging audits. A better approach would be to reconsider the preceding decisions in the context of an ISO QMS and to resequence the startup activities. To sum it up, labs can get to accreditation and sustainable revenue generation. They can't get there because they can't get through validation. Standard operating procedures, referred to as SOPs, and validation procedures are another area where common mistakes occur. When acquiring instruments, labs are often convinced that the equipment comes complete with turnkey SOPs. The reality is the supplied instrument documentation is a combination of OEM marketing materials and application notes that provide only 30% of the content required of a usable SOP. While the application notes are a good resource for reference, they do not conform with ISO 17025 requirements for document control and are not cross-referenced with the QMS. The application notes also omit critical technical content, such as realistic matrix attributes, quality control procedures, instrument work lists, corrective actions, and a myriad of technical details that are required to guide a technician through the proper execution, evaluation, and reporting of analysis results. To make matters worse, when validating methods, there's a large amount of confusion resulting from the immaturity of the industry, coupled with marketing ploys that suggest an application note is validated to the extent required by the lab. Often, a lab begins with a validation and nothing more than an OEM application note, possesses no written validation procedures, and is armed with only state-dictated performance requirements. During validation events, a lot of data is generated, but there is little thought invested into a structured design of experiments to ensure the right data and the right amount of data is generated. In fact, some labs miss the most fundamental step of ensuring all equipment is calibrated and traceable to a national standard prior to commencing validation activities. Over-reliance on application notes, coupled with inadequate validation procedures, ultimately yields either SOPs that cannot be validated or validation events that need to be repeated, costing the lab precious time and wasting consumables and money. Lastly, we see startups operating on shoestring budgets with skeleton crews who are struggling as they juggle multiple responsibilities and serve as first responders to daily surprises. This situation distracts personnel from receiving critical training, carrying out proficiency testing, overseeing calibration activities, and building out the QMS. The laboratory personnel who are closest to the revenue-generating work are stretched so thin that they neither develop the foundational competency required to perform their responsibilities nor perform billable testing. This situation, as well as ever-growing pressure to become accredited, weighs on personnel and even causes employee turnover, further extending the timelines and increasing overall costs. As you can see, there are many opportunities to make mistakes when starting up a cannabis lab. Cumulatively, these mistakes, combined with others, cause months of avoidable delays, loss of business revenue, and puts the lab at economic risk. Labs that are lucky enough to survive this phase are not in the free and clear. Looking forward, an operational model based on an unstable foundation has more costly risks ahead. Cannabis labs are the most technically difficult types of quality control labs to open. Narrowing in on cannabis testing, accurate measurements are significantly more challenging when considering the diversity of chemical and microbial characteristics of cannabis. Given the state-imposed acceptance criteria and lack of standardized methods for cannabis, each lab is left to develop their own expertise. In circumstances such as this, Quality control measures are paramount. Each step along the cannabis product's journey in the measurement process, starting with sampling, transportation, sample preparation, and ending with testing, can contribute to inaccuracies and uncertainties in the measurement. Labs must fully understand all of the variables that contribute to uncertainty and institute adequate quality controls to manage and minimize the risk of inaccurate measurements. Laboratories with poor or neglected management systems often produce inaccurate and non-defensible test results, which affects the stakeholders and the financial viability of the lab. Since most required testing is designed to ensure the safety of cannabis products, inaccurate test results place the consumers at serious health risk. Depending on the origin of inaccuracy, it can affect multiple analyses, including foreign matter inspection, residual solvents, heavy metals, pesticides, and microbials. The laboratory investors, as well as cannabis producers, are put at risk when inaccurate and non-defensible results of analysis are published. With no margin for error and tight tolerances for acceptability, inaccurate analyses can conclude with a false acceptance or a false rejection of cannabis products. In the case of a false acceptance, potentially unsafe products are permitted to go to market to be sold. Beyond the health risks to the consumers, the labs and the growers face product recalls, substantial fines, and other penalties imposed by the state. Alternatively, a false rejection means that growers potentially lose out on hundreds of thousands of dollars in income as they must destroy all of the affected product. Both situations lead to undesirable outcomes. The stakes are high and the lab's reputation is on the line. Frequent incidents of incorrect test results will cause the lab's clients to lose confidence in its credibility and look elsewhere for a more reliable service. However, with appropriate quality controls, these risks can be managed and minimized. By now, it should be clear that there are a lot of challenges and risks involved when starting up and operating a cannabis lab. The unanswered question is, what solutions can be implemented to prevent the problems and yield sustainable, profitable revenue? With so much on the line, a comprehensive solution and business strategy is needed. The solution needs to emphasize the importance of quality and put it at the forefront of every decision. This begins with quality as a strategic business plan and follows with quality as an operational model. The next step is to recognize that people are the most important resource and ensure the lab has the right people at the right time, and to focus on building competency and enabling knowledge transfer. Finally, a fully functional ISO QMS tailored to the cannabis lab needs to provide the framework for all activities that occur when starting up and operating the lab in the long run. Commitment to quality is a winning strategy. With quality as a strategic business plan, the plan is unrelenting by placing quality at the forefront of every decision and establishes a stable foundation for every subsequent decision. Practically, this involves changing the sequence of events by implementing an ISO QMS in the very beginning of the startup process. This is critically important because all decisions must consider what is needed to deliver accurate and repeatable test results. The requirements for what is needed is usually governed by state-regulated limits and client expectations. Understanding needs can ensure that the facility, environmental controls, adjacent activities, security, instruments are all selected and verified to enable the delivery of reliable test results. The QMS should be considered an input to the business plan because it provides 25% of the content required for a comprehensive plan. Next, an operational business model needs to be created and shared with everyone who is involved in the decision-making or performing activities that affect quality. This model starts with a commitment to quality. The business model rests on an unrelenting commitment to the QMS, ensuring that everything that affects the quality of testing is understood and governed by the QMS. This foundation supports four key pillars of people, process, infrastructure, and tools and technology. With this model, the lab can generate sustainable and profitable revenue. Visualizing the operational model in this way reveals the dependency of the entire structure on the management's commitment to quality and follows with the reliance on a well-structured, carefully planned, and implemented QMS. Once quality is solidly established as the foundation and an operational QMS is in place, the next step is to define the credentials, competencies, and values that are required of future laboratory personnel who will ultimately be responsible for the test results that generate sustainable and profitable revenue for the lab. This eventuality reinforces the principle that people are the most valuable resource for the lab. It follows that the requirements for personnel need to be defined and that the candidates are carefully screened against the required credentials, competencies, and values. The personnel requirements are an integral component of the QMS and are identified as competency requirements. Understanding who is needed and when is equally important. A quality manager should be considered a high priority position to oversee all aspects of quality during startup mode. This is one area where professional consultants can add temporary capacity and independently manage the implementation of the QMS as the lab's team is feverishly working to commence method validation. Since people are the most important resource, priority must be placed on transferring knowledge during the startup to enable the laboratory personnel to function independently of the instrument manufacturers and consultants when they move on to other clients. The lab's operational model needs to include provisions to further the development of its personnel, thereby increasing the collective competency and ensuring the lab can succeed in delivering accurate and reliable results without constant intervention of external support. Through phase 3, we see talented consultants who arrive to provide method validation services and then depart without transferring knowledge to the lab's team, leaving them unable to repeat the validation and unprepared for an audit. It's important to know that ISO 17025 is a competency standard for the laboratory personnel, not the consultants. Hiring consultants that don't transfer knowledge is a waste of an invaluable opportunity to embed competency in the lab. Now that the business plan and operational models establish quality as a strategic value and that people are recognized as the most important resource, the lab needs a construct to operate within. This is where the ISO QMS enters. The QMS provides a written framework for the lab to operate within. It contains all of the crucial policies, procedures, work instructions, forms, and records needed to ensure consistency while operating the lab. Consistency is required to attain predictability, a key ingredient of accurate and reliable test results. With the QMS being such a foundational component of the lab's operational model, it's important to consider proper construction of a QMS. So many labs try to pinch pennies by developing their own or acquiring a generic template. While these approaches offset near-term cash flow, they require a heavy investment of time. Because of the haste to patch a QMS together, it's suboptimal, fragmented, and inefficient. Ultimately, the short-term savings result in a huge long-term loss of value. An effective QMS should require minimal effort to use and maintain. It should be accessible to all laboratory personnel and be cross-referenced to ISO 17025, state regulations, and the accrediting body's requirements. Currently, ISO 17025 has 220 requirements, and the QMS needs to fulfill all of them and designate storage locations for the records the lab produces. Accrediting bodies who assess the labs are often more lenient in the beginning when labs are starting, but become much more stringent as the lab matures. The key point is to understand that the QMS should comprehend both the near-term and long-term needs. It should be in continuous use and undergoing continuous improvement as the lab matures. Here's a question. Does a QMS actually provide a return on investment? Consider this. A lab invests $150,000 for an instrument that contributes to 10% of its revenue. The instrument requires ongoing maintenance, calibration, and has a finite life. In contrast, the management system supports 100% of the lab's revenue and provides the long-term foundation for how a lab will operate and ultimately succeed. Both the instrument and the QMS require a high degree of technical competency to start up and operate. Yet, the weighting of the instrument investment is disproportionately out of balance with the investment in the QMS. It almost seems absurd that investors are willing to compromise the very most foundational component of starting up and operating a cannabis lab. Neglecting to account for a QMS is costly, but it doesn't need to be this way. A $150,000 investment in a QMS and professional support can completely flip the curve from a cost of delay to a positive return on investment, delivering up to $2.7 million of value in the first 18 months. So where does all of this lead? Clearly, cannabis labs have a lot of economic potential and can be profitable investments. The number one reason they struggle to start up and remain profitable is because of an incorrect mindset that loses sight of the ultimate value of its services. Most people consider a QMS to be a necessary evil of running a lab and either try to avoid it or treat it as another thing to do. However, the mindset needs to shift to one that emphasizes the QMS as the way to work, and by doing so, the lab will produce profitable results. Beginning with the end in sight, meaning focusing on the predictability, accuracy, reliability, and timeliness of test results, will ensure the laboratory, personnel, and investors are always working in the same direction. As such, the QMS, SOPs, and validation protocols should be considered just as important as, if not more important, than investments in instruments and other physical assets required to operate the lab. The laboratory personnel who ultimately perform the billable work should be considered the most important resources of the lab. The lab must get the best people who are competent and naturally committed to quality. Laboratory personnel should be provided with training and time to develop deeper competencies in all aspects of the work they perform, as well as with the QMS. So, is it too late if you've already started or have been operating a cannabis lab without quality as a strategic plan and an operational model? Absolutely not. It's never too late to renew your commitment to quality and convert to a robust management system. Quality is the inevitable strategic plan and operational model. Labs that embrace this will have a profitable business for years to come. Thank you for your time and attention today.